Alright, so in this problem we're given a situation where an 8-gram bullet, let's do this first math, 8 grams, so we're probably going to work with kilograms, so let's just convert that real quick to 8 times 10 to the negative 3 kilograms. Okay, so this 8-gram bullet is shot into a 4-kilogram block at rest on a frictionless horizontal surface. The bullet remains lodged in the block. The block moves into an ideal massless spring and compresses it by 8.7 centimeters. And as well, let's convert this to, let me see, 0.087 meters. The spring constant of the spring is 2,400 newtons per meter. So now we're being asked to find the initial velocity of the bullet. So the first thing we can do is try to determine what the initial velocity would be of this. So let's see. For the bullet, the initial velocity is going to be equal to the mass of the bullet plus the mass of the block times the final velocity. So now the final velocity is going to be equal to the mass of the bullet over both masses times the initial velocity, and that's just this equation being rearranged. So now that we have the equation for the final velocity, we can actually plug this in right here, and that'll give us the equation that we can use to solve. So let's do that first. The initial velocity is going to be equal to the mass of the bullet plus the mass of the block over the mass of the bullet. And now here we're going to have our spring constant, so we're going to have k times x squared over both masses again. And we derived that from the final velocity squared. So if we have the final velocity squared, it's going to be equal to the spring constant squared over both masses. So we plug that in here. So now let's just plug in the values that we do have. So we know that the mass of the bullet is 8 times 10 to the negative 3 plus 4. And then this is going to be divided by the mass of the bullet, 8 times 10 to the negative 3. And now we're going to multiply it by the spring constant, which is 2,400 times 0.087 meters squared. And now we're going to add both masses. So the 8 times 10 to the negative 3 plus 4. And now that if we simplify this and put in the calculator, this first value is going to be 501. And then this is going to be 4.5. So now, when we multiply these values, we actually get 200, 270. And then when we divide this value by 2, because we're supposed to add a half over here, but I like to keep that till the end. So we divide this value over here by 2, and that gives us 1135 as the initial velocity. And now when we look at the answer choices over here, the one that's closest to 1135 is going to be C, 1100.